Hello students. Today we will see the conformal mapping. So what do you mean by conformal mapping? So first of all, let us say what do you mean by mapping. Now whenever you plot any complex number, so here we are talking about the complex number say z x plus iy, right? So if I want to plot this number on a paper, what I'll do is I'll take a two-axis picture, that is a plane. This is the real part of z that we are going to plot on this, and the imaginary part of z that we are going to plot on the y-axis, right? So for example, if you take a complex number say 2 plus 3i, then how will plot this? So 2 on x-axis, this is 2, 3 on y-axis, so this is 3, so this is a point. Okay, this point is 2 comma 3. This represents the complex number 2 plus 3i. Okay, so this is a complex plane. We will call this as z plane. Z plane. Okay, now whenever I want to transform this, so I am going to apply a function on this. So let me take f of z to be equal to say 2z. Okay, so what this function is doing, it is taking a complex number and it is making it 2 times. Okay, so you are getting a new complex number. Now this new complex number, let us call this at w. Okay, so how w will look like and where you will map this? So this particular function maps this plane onto a new plane. So to map w, now see that w is again a complex number. So we need a plane for representation for this. So we will say this is the real part of w and this is imaginary part of w. Okay, if I take the same example, say 2 comma 3, then of course w will be what? It will be 4 plus 6i. So where it get mapped? It get mapped to say 4 is here, this is 4, and 6 is suppose here. So this is the point 4 comma 6, right? So what we are doing is, under this particular function, we are making two pictures now. One is the input, that is the z inside, called as z plane, and to map the output, that is w, we have another plane called as w plane, right? So what we are doing is we are transforming complex number from this plane to this plane. Okay, and this transformation is because of this function. So this function here, this f, is called as a transformation or a transform, right? So we will say this as a map or a transform, and then it transforms the complex plane to certain complex plane. Now we need to study this. Now what do you mean by studying this? So considering different functions, okay, what will happen to the figures over here to display? For example, suppose I take a circle, a unit circle in z plane. This is of radius 1, a unit circle that is centered at 0. And if I transform this, so let me take the transformation as say 1 by z. Okay, what will happen? What kind of picture I am getting as an output? So I am interested in studying these kind of things. Okay, and this is called as a mapping. This is called as a mapping. Okay, so this is one part. Another thing is that what do you mean by now conformal mapping? Okay, so I'll just add few words in this. Suppose let me draw here the z plane. Okay, so suppose this is my z plane. This is z plane. Okay, and for the output, we will draw here a W plane. Okay, so this is my W plane. This is W plane, right? So Z plane, that is the input complex number, W plane is the output complex number. Okay, fine. So suppose let me take here two curves. Uh, so this is a curve, say C1, and this is another curve, say C2, and these two curves are intersecting in the Z plane. Okay, then they are intersecting with some angle theta, right? Okay, now if I take a mapping from here to here, say f of z. So f of z is a mapping from this plane to this plane. I'm interested in what will happen to C1 and C2. Okay, so C1 gets mapped to some kind of object, some kind of curve over here. C2 gets mapped to some kind of curve over here. Okay, they may be intersected somewhere else on the plane. But if the angle between the two curves in z plane remain constant, so suppose I take that this is say d1, this is a image of c1 under this function, and this is say d2, this is c2's mapping in the w plane. Look at this angle, say I'm calling this angle say phi. Okay, so the mapping f of z will be conformal. Okay, if this angle gets preserved, that means if theta remains unchanged. Okay, if the angle between the two intersecting curves remains unchanged, the mapping is unchanged in the sense unchanged in the magnitude, that means the amount of the angle, and in the sense, that means in clockwise or anti-clockwise sense. So that sense also remains constant. Okay, so if this angle is anti-clockwise theta degrees, then the same angle we will get over here, provided the mapping this f of z is conformal. Okay, so conformal mapping preserve angle. Okay, so please keep this in mind. Okay, and we'll see the examples in the next video.